we're looking at the types of equations. First type, linear equation. Let's move to the next one. This is quadratic equations. Okay, so quadratic equation has a very specific type of representation where the highest power of x is 2 and it keeps on reducing. For example, the general format will be ax square plus bx plus c. Now, we have two types of quadratic equation. The first format is called as a pure. Okay, in the pure form, we don't have b. Okay, so b is equal to 0. This means simply we have ax square plus c is equal to 0. This is a pure form of quadratic equation. And the second form is called as adfacted. This is adfacted, adfacted form where the b is not equal to 0. Okay, so both a and b will exist. A is not equal to 0 and b is also not equal to 0. So we come back to the original format, ax square plus bx plus c is equal to 0. This is the form. Okay, this form itself is called as the standard form of this is referred to as the standard form of the quadratic equation. All right, now in case of the standard format, right, you can try to find the root of an equation, right? The roots are obtained by using the following, right? This is roots can be found by using x is equal to, this is minus b plus or minus, this is root of d whole divided by 2a. So a is given in the equation, b is given in the equation, and we can use this to calculate the value of the root. All right, now depending upon the value of d, we have varieties of roots possible. So we look at the nature of the roots, right? So we'll see, we'll say what is d. So d is equal to, this is b square minus 4ac. All the values b, a and c are available, right? They are available in the given equation itself. So now let us try to find the nature of roots provided all the values a, b, c, they are real. Okay, they belong to this, and a is not equal to 0. If this is the case, then let's look at the various conditions now. So let's say the d value is less than 0, right? This d is negative, so root of negative will not exist. So, right, non-real complex roots, this implies the roots are non-real complex roots. Okay, next, if say d is greater than 0, right? D greater than 0 means we have root of d as a real value. So we have two real and distinct roots. So x value will be real and distinct. So we have real and distinct values coming into picture. Right. So how to write the equations in that case? So what are the roots? Let's write first. First root, x1 is equal to, this is minus b plus root d by 2a and x2 is equal to, this is minus b minus root d divided by 2. And we can factorize straightforward method. Ax square plus bx plus c can be factorized simply as a into x minus x1 first root into x minus x2 second root. Okay, then we go to the third condition. This is if let's say d is equal to 0. This is the condition 1, condition 2, and d equal to 0 is the condition number 3. If d is 0, root of d is also going to be 0, right? I have only minus b divided by 2a. Both roots will remain same. So that means x1 is equal to x2 is equal to minus of b divided by 2a. So this suggests that both roots are same. So when both roots are same, we are calling it as real and repeated roots. So real and repeated. Okay, real and repeated roots. All right, then let us try to write some more important points. Now, this acts like a note. Let us say in this given equation, the a plus b plus c becomes equal to 0 somehow. Okay, and all the ABC, a comma b comma c, are let us say they are rational. Okay, then 1 is a root of that particular equation. Okay, then definitely this given equation is going to have a root as 1. So this implies one of the root is 1. So quickly we can go and we can write one of the roots in the easiest fashion. So directly I can write that, okay, if this is the case, then 1 is a root. Once I find one root, I can find the other root. Okay, then in the same note, we have another point to make. If at all we observe that a square plus b square plus c square minus ab minus bc minus ac is half, then there is one more condition that gets satisfied by automatic, right? By virtue of the equation is, that is this. If that is satisfied, then a minus b whole square plus b minus c whole square plus c minus a whole square, right? This can be simply equated to minus of a minus b into b minus c plus b minus c into c minus a plus c minus a into a minus b. So this will get satisfied. We use this several times in our problems to save some time. Okay, all right, let's try to solve basic problems associated with the quadratic equation, right? This is one of the repeated question. Find x, in the sense it is to solve the question. So this is 5 plus 2 root 6 to the power x square minus 3 plus 5 minus 2 root 6 5 minus 2 root 6 to the power x square minus 3 is equal to 10. Okay, now there is one property that I need to observe here. That is, I observe something. So there is one term called 5 plus 2 root 6. Okay, this is actually equal to the inverse of the other number, 1 divided by 5 minus 2 root 6. So I can write 5 minus 2 root 6 as, this implies I have 5 minus 2 root 6 in my equation, which can be simply rewritten as 1 divided by 5 minus 2 root 6. I can rewrite in this way. So that means my equation now changes to 5 plus 2 root 6 to the power x square minus 3 plus, this is 5, okay, there is a 5 minus 2 root 6. I'm going to replace it as 1 divided by 5 plus, okay, so this is 1 divided by 5 plus 2 root 6 to the power x square minus 3 equals to 10. Okay, now let us make another assumption here. This helps us in solving the question in an easier way. So let t is equal to 5 plus 2 root 6. So this implies 1 divided by 5 plus 2 root 6 is equal to 1 divided by t. So the above equation becomes, this implies, so I can, okay, I'll raise it to the power, even the power I'll raise. So this is, let t is equal to x square minus the power. So this implies this power to the power x square minus 3 becomes equal to 1 by t. So this implies the given equation is simply now t plus 1 by t is equal to 10. Right? So starting from a complicated notation, we reduce this to a simple notation. Now let's see how to solve this. Okay, so I cross multiply, so I take a common denominator. So this is t square plus 1 divided by t is equal to 10. This means t square plus 1 is equal to 10t, right? So my equation becomes t square minus 10t plus 1 equals to 0. So this means let us try to solve this equation to get the values of t. So therefore t is equal to minus of minus 10, so plus 10 plus or minus root of b square is 100 minus 10 square is 100 minus 4 into 1 into 1, so 4 whole divided by 2a. A is equal to 1, so this is divided by 2. Right, so I can see that the t itself is equal to, this is 10 by 2, so 5 plus or minus root of 96. 96 is 36 into 4, so okay, this is 96. 16 will take out, 16 becomes 4 by 2 is 2 root 6. So we have both the roots of 5 plus 2 root 6 and 5 minus 2 root 6. Okay, all right, now this means it's very clear. So what was t? T is equal to this number, but what was t? Originally we assumed something as t, correct? So that is this, right? 5 plus 2 root 6 is what I am assuming, right? So this implies one of the root is 5 plus 2 root 6 to the power x square minus 3. So this should be equal to one of this root. One of the root is same as 5 plus 2 root 6. right? It is power 1. So ಈ ಪವರ್ ಅನ್ನು ನಾನು ಈಕ್ವೇಟ್ ಮಾಡಬಹುದು. This implies x square minus 3 is equal to 1. Okay, this can be even plus or minus 1, right? Because I can write this is plus or minus. When it is minus 1, it goes to the denominator, right? So 5 plus or minus this, I can actually rewrite this as 5 plus 2 root 6 to the power plus or minus 1. So ನಾನು ಹಾಗೆ ಬರೀತೀನಿ. So this could be plus or minus 1, right? Equate the powers. So I have two options. First option is x square minus 3 is equal to plus 1, or the x square minus 3 is equal to minus 1. All right, so this means let's try to solve this. First equation, x square equal to 3 goes to other side plus 4. So x is equal to, right, plus or minus root 4, that is equal to plus or minus 2. One answer. The other answer is x square is equal to minus 3 goes to other side as plus 3. Plus 3 minus 1 is plus 2. So x is equal to plus or minus root 2. So the answer for this question, what's the value of x that satisfies the given equation, is x is equal to plus or minus 2 or plus or minus root 2. All right, next we go to some of the relationship between the roots and the coefficients. In a quadratic equation, we are trying to write the relationship between the roots of the equation and the coefficients. Okay, so let us start with the equation, that is ax square plus bx plus c is equal to 0. Okay, and let us make sure that a can never be equal to 0. Let us assume that we have roots are real and distinct. Let the roots are real and distinct. So we have two roots. So let us assume that one root is alpha, which is less than beta, because they are not equal. So it has to be different. Let me assume that one of the root is lesser than the other one. You can do the reverse. Beta less than alpha will work. Okay. Now let us identify some of the relationships between the roots and the coefficients a, b, and c. Okay, to start with, let's write the first relationship is, okay, let's write what is alpha. Once again, this is already we know, minus b plus root of d divided by 2a, and the second root beta can be calculated as minus b minus root d divided by 2a. Okay, roots are real and distinct, then we can try to write it in this way. If this is the case, then this implies what will be the sum of roots. All the roots, when you take the sum of roots indicated by s, which is equal to alpha plus beta, right? This can be simply calculated as minus of b by a. So sum s can be simply calculated as minus of what is b. B is the coefficient of x. Coefficient of x divided by the coefficient of x square in the equation. That is a and b we are using to find the sum of the roots. Okay, then let's go to the next shortcut formula. This is to calculate the product of the given roots. So s, okay, s is already used. I'll use a letter p for that. So the product p is equal to alpha beta, right? This can be easily calculated as c by a. right? So what is the product? Product can be calculated as the constant term in the equation, the constant divided by coefficient of x squared. Of x squared in the equation. All right, so we know how to find the sum of the roots, how to find the product of the root. Then we can also calculate the difference of the roots. Difference of roots denoted as d, which is equal to the alpha minus beta, can be calculated as the root of okay, let me denote this is d dash, okay, because I'm writing a d over here, d by a, right? You can actually replace this d as b square minus 4ac divided by a, right? This d has a name now, so d difference d dash is equal to square root of the d is called as a discriminant of that particular quadratic equation. So this is discriminant divided by the coefficient of x squared. Right, now let's say how to form a quadratic equation, provided you know some of the details. Right, so if you know the values of s and p, I can write it in the following fashion, right? So if this is the next point under this, if say sum, that is s, and p, the product of the roots are known, then the quadratic equation is, directly we can write it is x square minus sum of the roots into x plus the product equal to 0. This is the direct equation we can write, right? You should know the product and you should know what is the difference. Right, this is the formation of an equation for a given root, right? I can simply write even if alpha and beta are known, I can write this. So for a given alpha and beta, simply calculate their product, simply calculate their sum, right, and put it into this equation. You get the equation corresponding to it. All right, then let's go to another property of the roots. It's called as a symmetric functions. Symmetric functions of root, right? Let us say the function of alpha and beta is said to be a symmetric function if it remains unchanged when alpha and beta are interchanged, right? So symmetric functions meaning, right, a function of alpha and beta whose value remains the same even if we exchange alpha and beta in that equation. For example, let's consider one example to make it very clear. Like say alpha cube plus 3 times alpha square beta plus 3 times alpha beta square plus beta cube, right? Even if you exchange the alpha and beta, this becomes beta cube plus 3 beta square alpha plus 3 beta alpha plus this is alpha cube. You can see that both are same, right? Such functions where even if you interchange the x and y, or sorry, alpha and beta, the function remains same. So any such functions are called as symmetric functions of alpha and beta. But now we are talking about the symmetric functions, and it is related only to the roots of a quadratic equation, right? We have two roots. Even if you interchange the roots, right, it should not alter. So we are looking at that that kind of function. So I'll give another example which is not a symmetric function. This could be something like alpha cube minus beta cube plus 5 times alpha beta. Now if we exchange, this is beta cube minus alpha cube plus 5 beta alpha. So they are not same, right? So this is not a it's not a symmetric function. So the first one is a symmetric function. The second example is not a symmetric function. Okay, now in order to find the value of a symmetric function in terms of, maybe you can have alpha plus beta, alpha minus beta, right? We can actually find that directly using the coefficients of the given matrix. Coefficients of the given equation, right? How to do that we can see, right? Here alpha and beta are the roots, a, b, c are the coefficients, right? If at all we have to calculate the alpha square plus beta square, right? If you want to calculate alpha square plus beta square, then we are going to use, right, this b square minus 2ac whole divided by a square. Okay, that's the equation. Next, if at all I want to calculate alpha square minus beta square, this is b into root of the discriminant by 2. We use randomly as and when we require any of such relationship, we'll use it. Okay, right now we are simply making note of all the such functions. If you want to calculate alpha cube plus beta cube, that is equal to minus of, this is b cube minus 3abc divided by a cube. Okay, moving on. If at all I want to calculate alpha cube minus beta cube, this has to be equal to root of d into, this is d plus 3ac all divided by a cube. Okay, now we use these properties to solve some of the next problems. Okay, so problem number 1 under this case, if one root of x square minus of root 5 into x minus 19 equal to 0 is 9 plus root 5 by 2. Find the other root. Okay, so one thing to note here is that the given equation or the coefficients of equations are not in the rational format. You can see root 5, which is not rational. It's irrational number. Rational should be something like 2 by 3, 1 by 2, okay, minus 1, plus 3, right? If you have something like this, then it is rational. So this is rational. The coefficient of x square, which is 1, that is also rational, but root 5 is not rational. So whenever the roots are, whenever the coefficients are not rational, right, then the other root will never be say, there is no question of having the roots being equal, okay, and even the root will not be the something like 9 minus root 5 by 2. It will not be in the same format, okay, so it will be something different, right? So because of that, now let me by comparing this equation with the x square, right, I know that it is minus s x plus p is equal to 0. I understand something. This implies the sum of roots should be equal to minus s is equal to minus root 5. So this implies sum is equal to root 5. So sum of the two roots should be root 5. Right. So one of the root is given. So alpha plus, let me call this root is beta, which is 9 plus root 5 divided by 2 is equal to the sum. Sum is equal to root 5. Right? So let us simply simplify this. This implies alpha is equal to, this is 9, okay, this is minus of 9 plus root 5 by 2 plus root 5. So this is equal to minus 9 minus root 5 divided by 2 plus root 5. So this is equal to minus 9 minus root 5 plus 2 root 5 whole divided by 2, the common denominator. So this means alpha should be equal to minus 9 minus root 5 plus root 5 is plus root 5 divided by 2. So this is the required answer. This is the next question. F difference between corresponding roots of uh, corresponding roots of the equations. We have two equations. First equation is x square plus ax plus b equal to 0, and x square plus bx plus a equal to 0. Right, here a is not equal to b, right? If that difference is same, then find a plus b is how much? Right, now let us assume something like we have two equations, right? Let us assume that the first equation has the x square plus ax plus b equal to 0. Let us say the roots are alpha and beta. So the other equation, x square plus bx plus a equal to 0, we should assume that the roots are, say, let's assume something else. So one is gamma and delta. So they are saying that in this particular context, they are given a condition that difference alpha minus beta should be equal to the gamma minus delta. So we go back and we'll check what is the equation to find the root of the find the difference, right? So we use that property. We already have written the difference. See, difference alpha minus beta is root of b square minus 4ac by a, right? So I just have to check corresponding. So it's a root of, so b square, a, for the first equation b square is nothing but it is a square, right? B ಜಾಗದಲ್ಲಿ a ಇದೆ, a square minus 4b divided by, it's a is 1. So this should be equal to under root, it's reversed, b square minus 4a divided by a. Okay, squaring both sides, we can get the following condition. So this means, this implies a square minus 4b should be equal to b square minus 4a. Let's bring the terms to the same side. This implies a square minus 4b minus b square minus 4a equals to 0. Okay, so let's try to simplify this. So I can write this as a square minus b square as a one term, a square minus b square, and I'll write the other term as minus 4 times minus 4 if I take a plus b. Sorry, minus 4a becomes plus 4a here. So the change is minus 4 if I take out b minus a, or I'll write it as plus. This is plus. I'll take 4 outside, a minus b equals to 0. So we can write the first term as a square minus b square, as this is simply a plus b into a minus b. A square minus b square can be split into a plus b to a minus b into 4 times a minus b equals to 0. Right, so I'll take a minus b common. When I take a minus b, I have a plus b plus 4 equals to 0. So see, they have given a condition in the question itself which says that a is not equal to b, right? So when I say a is not equal to b, this means in the equation a minus b is not equal to 0. This implies a minus b cannot be equal to 0, right? ಈ term 0 ಆಗಕ್ಕಾಗಲ್ಲ, ಇದೇ 0 ಆಗಬೇಕು. So this means a plus b plus 4 equals to 0. So what is a plus b is equal to minus 4 is the required answer for the question. All right. Okay, then moving further, the next concept is called as the transformation of quadratic equations. All right, now Once again, we'll come back to the same equation. Let's say we start with the equation ax square plus bx plus c equal to 0 with alpha comma beta as the roots. Okay, now I want to write the equation, right, with roots. So if I want to change the roots as alpha plus a constant k, and beta I want to change as beta plus some constant k, right? Originally say alpha was 5, beta was 8. So now I add k equal to 3, which means I want to change my equation to, right? This is equation with the roots as 5 plus 3, that is 8, and 8 plus 3, that is 11, right? So you see beta plus k, beta alpha plus k, that is 5 plus k 3, 5 plus 3, and 8 plus 3. So like that. That's what is a beta plus k and alpha plus k. If at all I want to change the roots to this, then the equation changes to, this implies the quadratic equation now changes to a into, this is x minus k the whole square plus b times x minus k plus c is equal to 0. Okay, now if I want to change the roots as alpha minus k, same constant term I want to subtract. Okay, if that is the case, alpha minus k and beta minus k. So the equation will change to a into x plus k whole square plus b times x plus k plus c equal to 0. See, ABC will not change. Okay, then let's change the root in a different fashion. So if you want to change the roots as, say, I want to multiply, so that is alpha k and beta k, then right, you multiply to the roots, divide to the equation alli ನಾನು divide ಮಾಡಬೇಕಾಗುತ್ತೆ. All right, so the equation becomes equal to ax square plus b into kx plus, this is k square c equal to 0. So this is what is the change that is going to happen. Similarly, if you say the roots are, that is alpha by k divide, okay, this is alpha divided by k and the beta divided by k. So then the equation changes to, this is a times k square x square plus b times k times x plus c is equal to 0. All right, then I change the sign of the roots, let's assume. Okay, so that means if you want to change the roots as minus alpha and minus beta, right, then the what you call, the roots will change, then the equation changes to ax square. So this is ax square minus bx plus c equal to 0. Okay, only root changes to minus of the original equation. All right, then let's go to the another variation here. If at all I change the roots to 1 by alpha and 1 by beta. So the equation changes to c into x square plus bx plus a equal to 0. Okay, then the next point, you change the roots from alpha plus b, alpha and beta to minus 1 by alpha and minus 1 by beta. So then the equation will change to c into x square minus b into x plus a is equal to 0. Okay, then next point, we want to change the roots to say k by alpha and k by beta. So the equation is going to change now as cx square plus k times b into x plus k square a is equal to 0. Okay, let's go to another point here. If you change the roots to p times alpha plus q and p times beta plus q, then the equation changes to a into, this is x minus q divided by p the whole square plus b times x minus p divided x minus q divided by p, x minus q divided by p plus c is equal to 0. Okay, we have two more points. Let us say we change the roots to alpha to the n and beta to the n. So in such case, the equation changes to a into x to the power 1 by n square plus b into x to the power 1 by n plus c is equal to 0. Whereas if I change the roots to simply alpha to the 1 by n and beta to the 1 by n, right, then the equation changes like this. This is a x to the n whole square plus b into x to the n plus c equals to 0. So these are the properties I need to remember whenever we are going to deal with the problems based on the transformations, right, of quadratic equations. All right, let's solve some of the problems now. All right, next question. If alpha and beta are the roots of ax square plus bx plus c equal to 0, find the roots of the equation ax square minus b times x into x minus 1 plus c into x minus 1 the whole square equal to 0. This is the equation. Find the root of this equation. So we'll start from the given equation, that is ax square minus bx into x minus 1 plus c times x minus 1 the whole square equal to 0. So what I do, I divide both sides by x minus 1 the whole square. So this becomes a x by x minus 1 the whole square minus b times x divided by x minus 1 plus c equals to 0. Okay, I'll convert this as a into x divided by x minus 1 the whole square plus b into x by x minus 1 plus c is equal to 0. So I take the minus sign inside, so this becomes 1 minus x. Sorry, I think I should write 1 minus x. Yeah, we'll make a change. So all the denominators becomes 1 minus x. 1 minus x, and this is also 1 minus x. Right, so if at all I try to write the alpha and beta as this, if you have this is simply x square and simply x, then the roots are alpha and beta, correct? So what I can try to write now is equal to, so alpha is equal to this value, beta is equal to the same value. Okay, so x by 1 minus x I can try to write like this. So I'll make one statement here. So alpha comma beta are roots of ax square plus bx plus c, right? So instead of x, I can see x by 1 minus x square. So alpha should be equal to x divided by 1 minus x. And beta is also the same thing. Beta is also equal to x by 1 minus x. So calculate alpha, calculate x from this, because what is x we want to calculate. All right. So this means alpha minus alpha x equal to x. So take alpha x to other side. So alpha is equal to x into 1 plus alpha. So this implies x is equal to alpha by 1 plus alpha. Right? Similarly, the other x, using the same technique, I can also prove x is equal to beta by 1 plus beta. So these are the roots of the given equation.